In this class, let us learn a purely inductive circuit. Inductor is a coil of negligible resistance. An inductor of inductance L is connected to an AC voltage. The AC voltage is given by V is equal to Vm sin omega t, where Vm is the voltage amplitude and omega t is the phase. Since it is a purely inductive circuit, voltage across inductor is equal to applied voltage V. So V is equal to VL, which is equal to the induced EMF L into di by dt. So from this equation, let us find the current through the inductor, I. Let us cross multiply. V into dt is equal to L into di. Therefore, di is equal to V by L dt, where V is Vm sin omega t. In order to find the current through the inductor, let us integrate di. I is equal to integral di, which is equal to integral Vm by L sin omega t dt. Let us take the constant Vm by L outside the integration. Integral sin omega t dt is minus cos omega t by omega. Therefore, current I is equal to Vm by L omega into minus cos omega t. But minus cos theta is sin theta minus 90. Therefore, I is equal to Im sin omega t minus pi by 2, where Im is equal to Vm by L omega, which is the current amplitude. But the phase value of the current is omega t minus pi by 2. Let us compare the phase value with the phase value of the voltage. For voltage, phase value is omega t. So we can conclude current lags voltage by pi by 2 in phase, or voltage leads current by pi by 2 in a purely inductive circuit. Now let us draw the phasor diagram. For an inductor, voltage is given by V is equal to Vm sin omega t. So let us draw the voltage phasor as OA with a phase value omega t. And the length of the vector is amplitude Vm. And current in this circuit is I is equal to Im sin omega t minus pi by 2. So phase value of the current lags by pi by 2. So it is drawn in the negative direction. Clockwise direction is negative. And it is represented by OB. OB represents current phasor. Now let us find the power dissipated in the circuit. Power at any instant is given by P is equal to Vi. Voltage is Vm sin omega t. And current Im sin omega t minus pi by 2. That is Im minus cos omega t. So power is equal to minus Vm Im sin omega t cos omega t is sin 2 omega t by 2. So instantaneous power P is equal to minus Vm Im by 2 sin 2 omega t. The average power is given by the average value of instantaneous power. So minus Vm Im by 2 into average value of sine 2 omega t. Average value of sine theta is 0. So the average power is 0. Power dissipated in a purely inductive circuit is 0. So inductor is preferred in AC circuits than resistor. Now let us see the graphical representation of voltage, current and power. Voltage is a sine curve, while current is a cos curve, or current varies as minus cos theta. Current lags behind the voltage by pi by 2. But for power, the frequency is 2 omega. So when voltage completes one cycle, power completes 2 cycles because the frequency is double. Thank you.